Selamat sejahtera. Hari ini kita akan membuat lab 3. Ini group member kita. Saya Xuan. Group member saya Choy Min Ze, Zhen dengan Syazwan. After we get out the anchor to a suitable position, we can put the jack stand to it. We are gonna use 2 jack stand to support the vehicle. To open the bolt, we have to use the gun, and before we use, we have to make sure the rotational of the gun is counterclockwise. Now it is counterclockwise, and we use a suitable 21mm to open the tire. Now before we be able to take out the drum brake, we have to remove the disc brake caliper. To remove the disc brake, we may remove the rudder also. So before we remove the drum brake, we have to remove these 4 screws to make us able to remove the drum brake. This the drum brake. Before we dismantle the drum brake, we're going to clean it using the air gun.
Then we start disassemble this. First, we remove all the spring here. Then remove.
Now we are going to measure the brake leading thickness by using the caliper. So before we using vernier caliper, we have to make sure the error is 0.00. So now we are going to choose here to measure. The first reading is 2.64 millimeter. We are going to take 3 different readings for 3 different positions. So now we take the second reading. So the second reading is 2.16 millimeter. Now take the another side for the third reading. So the third reading is 2.32 millimeter. So after we measure the first bread reading, we are going to measure the second one as well. We also take 3 readings from the second bread reading thickness. So the first reading is 2.21 millimeter. Now we take a different position for the second reading. So the second reading is 2.11 and 2.12 millimeter. For the third reading, we'll to the other side. So the third reading is 2.42 millimeter. And now we are going to measure the inner diameter of the breadcrumb. So before we are going to take 4 different readings for the diameter. So before we do that, we are going to use the chalk to plot 4 different lines as our measurement. So first line, second line, third line, and fourth line. After we mark the chalk, we are going to use the vernier caliper to measure the inner diameter. The first reading is 167.81 millimeter. For the second reading, it is 167.67 millimeter. For the third reading, it is 167.59 millimeter. For the last reading, it was 167.66 millimeter. And we are going to measure the shoe and lining thickness. So the reading is 12.57 millimeter. We are going to measure the other side as well. The reading is 12.36 millimeter. We are going to check whether the inner surface of the breadcrumb is not rusty and not even. So for testing, we are going to use the shoe and lining assembly to rub the inner surface to check whether it will move smoothly or rough. So as you can see, the shoe and lining assembly moves smoothly inside the inner surface of breadcrumb. It shows that the inner surface of breadcrumb is not rusty and the surface is even and smooth. So if the movement is not smooth and not even, we are going to change a new shoe and lining assembly. Now we are going to inspect the condition for each part of the drum bread. For the first part is breadcrumb. Condition is looking good. The second part is the maintenance spring. From the observation, it looks a little bit dirty, but it's not very rusty, so the condition is quite well. For the third part, we are going to check the lining and shoe assembly. From the observe, it looks like a little bit rusty, but the condition is still good. For the next, we are going to inspect the shoe-to-shoe spring. For the spring one, the condition is quite well. For spring two, the condition is quite well as well.
Okay, one. Okay.
Next, we will check the condition for the piston. As you can see, the condition of piston is not rusty and very well.
Okay, then first, okay. Now we go to the final process. Now we must assemble back all the brake drum.
Okay, now we are going to talking about the result. Firstly is drum brake part name. The first part is brake drum. Second part is return spring 1. Third part is shoe to shoe spring 1. Fourth is adjuster lever. Fifth is adjuster screw. Sixth is return spring 2. 7 is shoe hole spring. 8 is retainer spring. 9 is shoe to shoe spring 2. 10 is lining. 11 is brake shoe. 12 is retaining ring 1. 13 is washer. 14 is handbrake lever. 15 is trailing shoe. 16 is fixing pin. 17 is brake tube. 18 is retaining ring 2. 19 is hub. And lastly, number 20 is brake shoe. Next, I'm going to talk about the inspection of condition of several parts of brake drum. The first part is brake drum. Is a little bit rusty. Second is retainer spring, is also a little bit rusty. Third one, shoe and lining assembly, the thickness is 12.57 mm. Fourth, we test about the first shoe to shoe spring is hard and not rusty, means the spring is not loose. Fifth is the second shoe to shoe spring is also hard and not rusty. And lastly, we test about the piston is on good condition, not rusty. And now we are talking about brake lining thickness. The standard value is 4.4 mm. First brake lining, after we choose 3 different positions, is 2.64 mm, 2.16 mm, and 2.32 mm. For second brake lining, the first position is 2.21 mm, second is 2.12 mm, and third is 2.42 mm. For brake drum inside diameter, we took 4 different points. The first point is 177.81 mm, second is 167.67 mm, third is 167.59 mm, and lastly the last point is 167.66 mm. Lastly, we talk about the shoe and lining assembly thickness is 12.57 mm.
Now we are talking about discussion. For first question, based on your finding, what is the condition of brake shoe lining? Should it be replaced with new shoe lining? So based on our finding, the thickness of first brake lining that we measure are 2.64 mm, 2.16 mm, and 2.32 mm, and thickness of second brake linings are 2.21 mm, 2.12 mm, and 2.42 mm. It is below the standard value, which is 4.4 mm, so it needs to replace the entire brake shoe assembly with new ones, and as this is safer and more efficient than attempting repairs. The second question, explain the result of drum brake inside diameter. The drum brake inside diameter that we measure are 167.67 mm, 167.81 mm, 167.59 mm, and 167.66 mm. We should compare this measurement with the manufacturer standard diameter and the maximum allowable diameter. If the measurements are within the specific limits, clean the drum surface and ensure that the brake shoes lining are correctly matched. If any measurement exceeds the allowable limit, replace the drum brake to maintain safety and performance. The drum brake within the specific tolerance ensure optimal braking performance and prevents excessive wear on the other components. The third question, if that crack found on the drum, can it be repaired? Explain the answer. If a deep crack is found on a drum brake, it cannot be repaired safely and the drum must be replaced. Attempting to repair a cracked drum is unsafe and not cost effective. Replacement is the only reliable and safe solution to ensure optimal braking performance and prevent accidents. Repair cracks may propagate under thermal expansion and repeat mechanical stress, increasing the risk of catastrophic failure such as drum fracturing during use. The drum's ability to dissipate heat evenly is critical for consistent braking performance. Crack alter the heat flow, potentially causing hot spot and uneven braking. The third question, what is the advantage of drum brake compared to disc brake? The cost of manufacturing of drum brake is lower. Drum brakes are simpler and less expensive to manufacture, making them more cost effective for vehicles. Drum brake more better performance in specific scenarios due to their design. Drum brakes can produce more braking force because of the larger contact area between the brake shoes and the drum. Less wear and tear. Drum brakes tend to wear slower than disc brake under normal use, especially in vehicles that carry heavy loads or are used for low-speed applications. Conclusion, in this lab session, we gain valuable practical experience in inspecting, removing and refitting drum brake systems, which are essential for ensuring vehicle safety. Through careful examination of the brake shoes, drums, springs and related components, we can identify wear patterns and detect potential issues that may compromise braking performance. The removal and refitting process underscore the importance of using appropriate tools and technique to preserve the functionality and integrity of the brake system. This hands-on section enhances our understanding of each component within the drum brake system and their specific functions, while also stressing the critical role of regular inspection and maintenance in maintaining optimal performance and safety. Any significant wear, damage or cracking in drum components demands immediate attention and replacement to avoid compromising safety. The lab further highlights the importance of precise measurements, careful attention to detail, and to manufacturer guidelines, providing us with a strong foundation to future work in brake system maintenance and repair. And that's all. Thank you.